Hello, I'm Nobby Clark, welcome to my workshop. I'm going to start a small project today, which I hope is going to be a one-day build. It doesn't involve a lot of machining work, but I want to make another vice stop for my mill vice. I have shown before the vice stop that I normally use, which is this one. This just fits into the T slot on the mill table. I made this, we've actually got a date on here, in 2020. It was a very quick build, just made out of bits and pieces that I had in the workshop. I just machined up an aluminium block. There's the bar here and this attachment are off I think it was a magnetic stand that I had. These are sort of spare parts, and it just has a brass bar through here, so that fits into the T slot, and then you can adjust the brass bar to go up against the workpiece here. And I've used this countless times. It works perfectly well. Really no reason to have anything else, but there's a lot of people on YouTube that have made vice stops that fit onto the face of the fixed jaw that fits onto here. So I've found a small piece of aluminium, decided to make it out of aluminium rather than steel. I think less likely with aluminium that's going to mark anything on the vice itself. So it's a simple construction basically. It just needs a groove machined in the center here that will fit over the face of the fixed jaw. That will then be cut through the center, so you've got two halves. Then you can have a screw going. I'm going to put the screw through the back here, just to pinch the two halves together, and I'm going to put a dowel pin on each side here as a sort of form of a guide, so the two pieces are guided together. So once that's in position, work pieces can be put in the vice and they will just butt up to the edge of this. You can buy these commercially. I think the company Edge Technology can supply you with one of these, but obviously sort of I guess it's going to be quite expensive, and this is not a difficult little project to make basically. This particular vice, I mean, I've had this for a few years now, and I guess these vices are probably made for the sort of world market, and unusually everything on this seems to be imperial measurements. The adjustment nut here is actually a metric size, but when I measured the jaws here, they come out to a sort of a nominal 3/8. Don't know why it has all sort of different measurements on it. Yeah, that's coming out actually exactly 3/8, 0.375. All the screws in here are imperial, so it's a bit of a mix and match really, but there we go. So what I've got to do is basically start by mounting this in the vice and then machining a 3/8 slot across here. Doesn't matter, that's going to be a sort of a tight fit on here, because once you've cut the two pieces in half, it only needs a tiny gap to lock that into place. So I'll get everything set up and take you through the process of making this item. Well, the first job is to set everything up to machine the slot through the centre of the piece here. To get the depth I need, I'm just going to use a very, very simple way to do it. To get the depth of this part here would just literally be to put the part up against the back of the jaw face, and then just gently score a line across here. And if that line ends up by being slightly too deep, that doesn't really matter, because I don't really want it to be any deeper than this, so that it remains sort of nice and square once it's mounted onto the top of the jaw face here. So that will give me a guide, and I can set that up in the vice jaws like that. Just use a couple of parallels, and then that can be mounted into position there. But what I've got to do first is to find the centre, and I'm going to use the DRO to do that. So what I'm going to do is mount the parallels a little bit further back, still put that in the middle, so it's going to hold things nice and square, and then I can tighten that in place. And I'm going to use my edge finder, but I'm going to edge find off the inside faces of the jaw on each side to give me my centre position. So I'll show that setting up in a minute. I had to search through the end mills I've got, and when I've not got any slot cutting end mills, but what I managed to find was this one. This is one I've had for years actually. There was a box of bits and pieces that I got with my Chinese mini lathe, including a few end mills, most of which are totally unusable because they were either damaged or not sharp. This one does look okay to me. I think these are called Clarkson end mills, but you have a special sort of collet device to go in the mill to take these. But this one seems okay, and it's a 3/8 of an inch one. I did do a quick test with this first, just to see if it was cutting reasonably well. So I just found a real scrap piece of aluminium, and I just cut a slot into the end, which it does look okay. And I've measured across here, and it is a nominal 3/8. In fact, just a fraction over 3/8, tiny bit over, and that fits quite nicely onto the top of the jaw face here. So I think that's going to be fine. So we're going to use that one after I've found the centre, but I'll set that up next. Okay, well, I've mounted the edge finder into position here, so I can just bring that down between the two jaws this time, and now I can measure off each side. Slightly, there we are. Do this several times just to make sure I get it right. So you've got to do this so gently. That's perfect. Okay, so we'll bring across to the other side. once more. That's great. So now we can zero the wire, go to half and move that across to get back to 0. It does look as though it's in the middle. So I'll lock the wire movement, and now we can move the edge finder out of the way and swap this over for my normal ER32 collet. Okay, well, I've taken the edge finder out and I've put my ER32 collet chuck in place. I don't have very many imperial collets. Most of the ones I've got are imperial sizes. I've got one or two imperial collets of sizes that I've used very often, but I didn't have a 3/8 one. But the nearest imperial one I could find that would take this was 10mm. And obviously, as the collets have got a fair bit of adjustment to them, it seemed to fit in quite snugly, and so I just locked that in place. I was using a huge spanner to hold onto the top of the collet chuck. I've got an ER32 spanner, but what I hold on the top of the collet, I use this really old King Dick spanner, and I've pre-adjusted that to the right size, and I just leave this near the milling machine all the time to hold the top of the collet chuck, and that works fine. It's, you know, a manageable size, not too heavy. So I'll mount that on and lock that tightly in place. So now we're ready to start our machining process. I'll just bring one of my little lights round so that I can see the line that I've marked on the end nice and clearly. There we are, so we'll get this set up now and start our machining process. I don't think this is the thing it's going to take very long to do, hopefully, so just bring that out slightly so I can touch off on the surface. A gentle cut to start with. It looks as though it's in the middle. I don't think this cutter is absolutely perfect, because it is putting up a little bit of a burr on the top. Not too bad, but obviously that's going to clean off quite easily anyway, so it doesn't really matter too much. I'll just run this across one more time, and then I'll bring you back when I'm nearer to the line I've marked on there. I'll probably just go a fraction below that line I scribed on there to make sure the end stop's going to fit comfortably onto the top of the jaw face. Okay, well I'll bring you back when I'm nearer to the line now. Okay, I'm ready for the final cut now. What I've usually done in the past, if I'm needing to cut down to a line on a workpiece, is I make tiny adjustments to the depth of the cutter, and just run it into the workpiece bit by bit until I actually reach the position. And so what I'm cutting now is actually only a skim out of the surface here, which will hopefully bring me down just a fraction below the line that I scribed. Well, that should in theory be fine. I've just moved the cutter up out the way, out of danger. Now we can just clean all this off. A bit messy because I've used WD-40 to lubricate the cutter. Hopefully that's going to be okay. I'm not going to unlock the Y movement just in case I need to cut any deeper. I should, if I need to cut more, I should be able to quite safely put the workpiece back in here and then make another cut. Hopefully I won't need to do that. It all looks sort of okay. Let's give it a wipe over. What I do need to do is just to deburr the top here. Let's do this very, very carefully. If I don't do that, the burr will stop it from seating down properly. Just do it very, very carefully on each side. Still a bit of a burr across the top there. Get the inside of that as well. Well, let's do a test fit and see how it's come out. Well, that does seem to be okay. It sits down quite nicely. I think that's going to be fine. Yep. Yep. Yeah, okay with that. So next job, well, before I cut the two pieces in half through here, I'm going to work out the position for the screw here, which will clamp the two parts together, and the two positions for the dowel pins. If I do that first, then once the part's been cut in half, everything's going to line up properly. So I'll do all the marking out there off camera, and bring you back when I'm ready to set this up and drill the various holes. Okay, well I've marked the end of the workpiece here where I want the dowel pins to be at each end, and the centre one for the locking screw. All of these items, the dowel pins and the screw, will come in from the back of the vise, not the front. I think it just looks a little bit neater. So I've mounted the workpiece on two of my extra thin parallels, and I've got them held in with a spring steel clip, which I'll show you at the end. And I've already lined up my pointer for the centre line, so all I need to do basically now is move along to these positions. So I've got the just make sure I've got the y-axis locked in position, so I can bring that down, and that pointer is now in the centre position. So if I just, sorry if my head gets in the way, but if I bring that down so that I can get the pointer centered up over that little cross mark, which it appears to be. That way, I think. Yep, that's okay. So I can put a centering drill in here. And mark that first position. I've just got to remember to use the right drills for the right holes now. I'm using the dowel pins. I'm going to use the 5mm dowel pins purely because that's all I've got. These are two of the dowel pins that I bought to use in my fixture plate, and they'll be a sort of a reasonable size to use in here, I think. And it will actually need a exact 5mm drill. It's a 5mm cobalt drill, and I did, oh here it is, I did do a test first on a scrap piece of aluminium with a 5mm drill and 4.9, and the dowel pin won't go in the 4.9, but it will quite nicely fit into the 5. It needs to be obviously a sliding fit anyway, so that it's there purely to guide the two pieces in and out, basically, so it doesn't need to be a real tight fit. It's surprising the difference. Well, you can just about, if that was being pressed in, that would be the perfect size, actually, 4.9, but it's going to be too tight for this job. Anyway, let's get going. And in with the 5mm drill. I'm not going to drill all the way through. I just want to drill it down to sort of a necessary depth. I don't want any of these holes to appear through what will be the front of the piece itself. So there is a depth stop on the milling machine, which I must confess I never really use. I've often used the DRO to give me various set depths, but I thought, well, this is good enough for this particular job. It's just to measure out the depth I want and put some tape round here. Rather, I guess you say, rather crude method, but in reality it does work quite well. And I've cutting fluid on there, and possibly not such a good idea actually, because the swarf has come up and it's pushed that bit of tape up, so perhaps that wasn't such a clever idea after all. Nobby. Let's pop that down again. Let's try the dowel just to see if that does slide in okay. Yep, that's going to be fine. Can't get it out now. I'll leave it in there. With suction holding it in. Right, so take the drill out. Just measure that down the side there. Well, if I'm very, very careful, I'll be all right. Let's put my little pointer in. Down again. And I've got to move along to this hole, not that hole. That's the bit. Let's just repeat that process. don't think I've drilled all the way through. Yeah, that goes in quite nice, and that's quite a nice sliding fit as well, so I think that's going to be great. What I'll probably do when I come to the assembly stage is put a tiny bit of Loctite on the end of the dowel pin to lock it into the lower section, so that it's only one side that's going to slide up and down. We'll set up now for drilling let's move the 5mm drill out the way so I don't pick that up by mistake, so I can drill the tapping drill hole. Whoops, actually I should put my pointer in first, shouldn't I, so that I can line everything up. Forgetting. Obviously I'm going to be tapping into a blind hole, so I'm going to be very, very careful doing that. And then I think what I'll do is, once I've separated the two parts, is to drill the clearance drill, although it's probably best to do it now, actually. I think which is probably a better option. Let's get that in there. Line that up. Oops. It's okay. Yep. Oops. Oh, fingers and thumbs today. I'm going to use a 5mm Allen caphead screw as the locking screw for this, but as there's no thickness here, I can't put not going to put a countersink into it. What I'm going to do is use the caphead with a couple of washers in between, one being a brass washer, so it won't mark up this side of the material too badly. Again, I've put tape around this to give me the correct depths to drill to. Just got to be very, very careful, obviously, with this, as it's a blind hole that I'm going to be tapping into. Just have to be extra careful with this. And that's it again, it started moving that tape up, the bits of swarf on the drill, but I think I sort of captured it enough of that to do it. But I think I will drill the clearance hole. I'll just have to work out the half depth position here to do that. Okay, I've put a piece of tape on here that's sort of approximately half the depth here, so I can just do a clearance, and I'm also using that same 5mm drill again. I guess it probably is easiest to do it at this stage, and added thing, of course, it will help guide the tap into position as well. Okay, now I just got to sort out a couple of 5mm taps so I can tap that thread into here. That will take my cap head screw into here. But as I say, I'm gonna obviously not going to countersink that into the top, but what I will do is have a couple of washers between. I'm going to use the chuck here to start off the tap to keep it sort of nice and square. I'll put some of this nice gooey cutting paste on here. Plenty on. So I'll just start this off and then complete it with a tap wrench. Probably blocking your view, aren't I? But hopefully that's enough to get it started. And of course the clearance hole is half the depth of this, so that should guide the tapping very nicely. Possibly gone in far enough, and then I could always complete the tapping of that once I've cut these parts in half. I don't know if that's gone down far enough. I think I'll probably go through the process of cutting this part in half and then complete the tapping then. Unfortunately I don't have any sort of bottoming taps, something that perhaps I ought to get for myself in popular sizes. Anyway, the next process will be setting this up to separate these two halves. sort of work out how I'm going to do this. I think the simplest way is actually going to be use a slitting saw. I have to look at what I've got in the way of slitting saws. I haven't got very many, but I'll have a look through and see what I can find. That will, I don't really obviously want to cut through this with a very thick a slitting saw, but if I can find a fairly thin one that I think will go through this okay. But anyway, I'll set all this up and bring you back for that. Okay, well, as I mentioned, I don't actually own very many slitting saws, but I've found one which I hope will do the job. It doesn't seem to flex very much. It seems quite solid. So the job now is to find the centre of the material here, so I can slice this into two halves. Obviously the easiest method of doing this is to use the DRO and use the slitting saw itself to touch off on the bottom and the top. I'm not going to run the machine while I do this, but what I'm going to use is some cigarette paper. I'll just tear a piece of this off so that I can get it in through here, and I've put the workpiece a little bit out beyond the edge of the jaws here so that I can get the slitting saw just underneath enough so that I can touch off against the bottom of them. If I can get the cigarette paper under here and then raise that up until it holds the piece of cigarette paper in position. So if I raise that up and that's be holding that quite tightly in position. Now I can draw that out. Well, first I'll set the zero out, the Z movement, move that out and bring that up to the top and do the same at the top, and then I can use the half function to find the centre of the material. Bring that across again and then take that down. So that it grips that in position. It's gripped it quite nicely. In fact, looking at the readout on the DRO, which you can't see, it is actually giving me the depth of this material anyway, which was roughly 0.745. So if I now zero that, set the half function, and then I can now run that down to zero the Z position. Too far, I think. I'll have it. Let's take it back to zero. There we are. So now I'm in the centre, looking at along from this direction. It looks okay there. So I'll lock the quilt. That's it. And now I'm ready to cut across there. What I would have liked to have done was, well, see if I can do is take that back as far as I can, which if I bring that up to the, before I do that, if I touch that off against the blade, what I'll do is move the material back just a bit, so it's gripped nicely. Slide that down firmly. Just check what that is. It's square. Yeah, that's okay. Touch that off and move that back. So I can now gradually bring that in. I mean, the ideal thing would have been to have moved that across to half the depth of this, because from what I've watched other people do, they've suggested that you cut the whole depth literally in one go, but I haven't got enough wire movement here to be able to get that back far enough to bring it across this way, so I'm just going to have to sort of cut through that bit by bit. So there we are, that's all ready to do that now. Just looking at the clock, it's coming up to lunchtime, so I'm going to stop for a bit, go and have lunch, and then the next stage will be hopefully cutting this through without any problems. Okay, the next job is to part these bits of metal off in the centre here using a slitting saw, which you saw me set up to find the centre position. I mentioned that I can't get the y-axis of the mill back in this direction enough to get the slitting saw behind the metal so that I can cut right through it in one go. But my thought was that if I start by cutting purely in the X movement until I break through on this side, and then move the bed in the Y movement back to cut through, that will then cut the rest of it in one go. So really we'll just see how we get on. Basically just going to clear a few bits and pieces off the bed of the mill here. I've got my cutting oil here on standby ready. Plenty of that's required, I'm sure. Mentioned the using the cigarette paper to set this up. I bought a load of this some time back to use for all sorts of operations, and you don't have tobacconists anymore, so I guess you can get it in supermarkets, places like that. But I spotted that they sold cigarette paper in the pound shop or dollar store if you're in the US, and you could buy a huge quantity of these packs for £1. Cigarette paper is something I haven't used for many years now. I literally stopped smoking about 37 years ago. The other thing, just to mention, where I'd tapped the hole through, and I mentioned I don't own any proper bottoming taps. My thought was, whether this is right or wrong I don't know, is actually to make one. I looked through all my odd taps and found this is only a carbon steel one of the odd taps I've got, and I ground the end off and used that, and that worked okay. So I suppose just for a one-off job that was okay to use. Right or wrong I don't know, but there we go. Anyway, let's get started. Obviously I'll just show part of this process, because obviously I'm going to take this very slowly. It will take quite a while to cut through here, so I'll get it started off and then bring you back when I'm almost all the way through. as I said, I'll stop filming here and bring you back when I've almost cut this through. Well, that's it. It cut through okay. Rather a scary part of the operation, but there we are. I guess that part's going to be a little bit on the hot side now. So obviously I've got quite a bit of deburring to do, but I'm quite pleased that that's cut through okay. Certainly appears to have cut through okay. So I'll give all this a nice clean up, and then I'll come back to show it in its almost completed form. Well, this brings me to the end really of this little simple one-day project. 2 parts. I've basically cleaned them up. I will go over them again and give them another clean up and deburr all round, just to take off. There's still some little sharp edges, but basically the little dowel pins will fit into here. I can obviously Loctite these into place to stop them from pulling out, although I don't really see that being a problem anyway, because once that's mounted over the top here, they're not going to require hardly any movement here at all really. But I suppose to stop these from falling out and getting lost forever on my workshop floor, it might be worth doing that anyway. So to lock the 2 halves together, I'm using a little 5mm cap head screw, and I've put a couple of washers on here, a steel one at the back and a little brass one on top, so that it doesn't mark up, or helps not to mark up at the top here. So that will just screw into here, and then that can be locked in place with a little 4mm Allen key, which I didn't lose. So that will quite nicely now fit on the face of the fixed jaw, and that can then be locked into any position. And it does lock on really firmly as well, which I'm very pleased that I've got quite a nice fit to this as well. And of course it could be mounted along here in any position required. Then it could be mounted right off the edge here as well, if I'm very, very careful. Because the thing basically is that I couldn't really have made this any smaller, but because of its size, it's obviously going to limit the size of material that I can actually use in here. So that can obviously be set to the position I need, and then any material that I'm putting in here will run up to the stop position here for any processes where I need to repeat a position. Obviously, if I'm putting much larger pieces of material in the vise, I can still use my original, just lean over you for a moment, my original vise stop in the T-slots of the bed of the mill if I need to. So I've got that option open to me as well. Each section, I make my videos in sections and then obviously as everyone does, joins all the sections together, and I realised I've made a couple of errors in what I was saying during the video. So a couple of mistakes I made was when I was talking about the collets I've got for my collet chuck here, and I mentioned I think that I didn't have very many imperial collets. In fact, I think I only have 3, and then I mentioned that all my collets were imperial. In fact, all of them are actually metric, and I've got a whole range of metric collets which actually go up to 16mm, and then the largest one I've got is 20mm, which is actually larger than is recommended that you use on this mini mill. It's just too big. But the reason for buying the 20mm one is to hold my electronic edge finder. Body of this happens to be 20mm diameter, so I've got a spare Morse taper 3 to ER32 collet chuck, and I keep this exclusively to use with the edge finder. The other thing I said, which was completely wrong, where I was talking about the end mills, and I said that I haven't got any slotting end mills. What I meant to say was I've got no slotting end mills, like 2 flute end mills in imperial sizes. I have got quite a few metric ones, in fact, but I used an imperial one because this was an imperial measurements of 3/8 of an inch. Perhaps I'll sort of look perhaps to get some in popular sizes, perhaps some imperial 2 flute mills, perhaps at a later date. Something I also do when I'm on any project, really, you probably thought, well, this could quite easily have been something that I just decided to make and just made this up as I went along, which you could do easily anyway. But what I like to do, even when I'm making something very, very simple, is to do a very, very, very simple, quick drawing. If I can get that in front of the camera there. I'm covering that top part up because under here has got my various projects under. I don't want you to see that yet. So I made a little drawing here of what I thought it would look like. I was going to make a couple of cutouts here, but that would have been no particular reason for it, really, other than appearance, I suppose. But then the drawing I made here, I just made some rough measurements on this related to the size of block that I'd machined up. It's useful to do that, and when I would recommend anyone to do that, even on the simplest project, just gives you some notes to refer to, so that you don't sort of forget measurements of things and what you were going to do, and also when you're drilling holes and tapping holes to lay out all the tools on the top of the mill, the bed of the mill all ready for use. Obviously, as I mentioned, we've got to be very careful that you don't pick up the wrong drill by mistake. So it's very much a matter of keeping your wits about you whenever you're working on the milling machine. Was there anything else that I wanted to mention? Yes, the slitting saw I used. It's this one. As I mentioned, I don't have very many slitting saws. I think I've only got 2 or 3. I think this is the first time I've ever used this one. It seemed quite solid and firm to use. I've got one which is even thinner than this, which I've also never used, and I'd be sort of rather scared of using that one, I think. But I have got one slitting saw which is very much thicker than this one, and I use that quite a lot for making a coupling piece, the slots in coupling pieces on various engines I've built. Rather than make an arbor, I bought this. This was quite inexpensive to buy, but the nice thing about this is that under this locking collar on the top, it has if you like, a stack of rings to take slitting saws with lots of different diameter holes in the centre. And the idea is that you, obviously with this all removed off the top here, you push the slitting saw down and it moves the larger rings out of the way, and then you can clamp that down firmly with this central screw here. What I normally do is get it roughly in position, then I lock this into the bench vise and then very, very firmly screw this down to hold the saw, so there's no way that it can actually rotate. This has a 1/2-inch arbor, and that is one of the imperial size collets I've got. So because I've a number of things that use that 1/2-inch size, the shaft here, if you like. Now I've probably watched dozens of videos with different people making vice end stops. There's so many people that have made them like this. I wouldn't sort of buy a commercially made one, because really why buy things that would make nice projects to make yourself? So most people are the sort of very well-known people on YouTube, like Tubal Cain, Mr. Pete, Quinn, Blondie Hacks have made these and showed the making of them and using them as well. But what prompted me to make this today was I found another channel to watch on YouTube, which is called the English Hobby Machinist. I've subscribed to the channel and I've been watching quite a lot of the builds that are being made on that channel. I'll put a link to that in the description below as well, and I have communicated with Mark, who owns that channel, and he very recently made one of these himself. He's got an ongoing project building a Stuart, I think it's a 10V engine from plans, where he's building every part of it and actually building parts which, if you bought it as a kit, would have been castings, but he's actually making all those parts. But in between various episodes of that, he makes all sorts of other things, and he made one of these recently, and I hope he doesn't mind that I've sort of actually copied what he's made here, although these all seem to look the same no matter who makes them, really. He made his slightly differently to mine. I think his one was made out of steel, but give his channel a look. He's an excellent machinist. He's making a fantastic job of this Stuart engine he's doing, and I think you'll enjoy his channel. Well worth your while to watch it and subscribe to it as well. I also mentioned earlier on that when I'm using parallels in the vise, these need a bit of a clean up now, to hold them apart and to stop them from tipping over while I'm trying to position a piece of material, I had been using a spring that I made out of spring wire. It's like piano wire, and that will go in there and hold the parallels apart against the faces of the jaws while you're positioning your material in place. And a little while back, a subscriber and viewer of my channel, who's Stuart, his channel is Stuart's Shenanigans. I mentioned him in an earlier video because he very kindly sent me one of his workshop stickers. He sent me some very, very nice spring steel, this is not strapping steel that you use on parcels, but it's proper engineering quality steel, very accurate in dimensions. This can be very easily cut with strong metal plate cutters. I've got a set of Stanley cutters which cut through this very, very easily, and actually gives you quite a nice finish. And these edges are not sharp, they're not like a razor edge. He did warn me, be very careful when you bend this, because if you bend it too tightly it would just snap. So I used actually a piece of material about that sort of diameter, and I just mounted that in a vise and then very carefully bent that round it to give me a position for it, and then that will now spring in quite nicely into the parallels and hold the parallels apart perfectly. So I tend to use this now rather than the wire ones that I made. He sent me quite a nice length of this material, sort of coiled up. So rather than make lots of different ones, he said you can make them all different shapes. I thought what I would do is make them as I go along, if you like, as required. So I'll just make this one, which is going to serve 99% of applications that I need it for. But then if another application comes along, then I can cut off and make another one. Now I did take note of what he said about bending this too sharply because it will snap, and to start with I used a piece of rod which was too thin, and he was right, it just snapped into, you see where it snapped there. But rather than waste those bits, I don't like to waste anything in the workshop. Material is so expensive. There's been situations where I've needed to use very narrow parallels, where that metal would actually be wider than the parallel itself. So in one or two instances what I've done is put the small parallels in and then just put these clips at each end. Be careful these don't spring out while you're doing this. You've got to be very cautious with them, and I would recommend, if you're doing anything like this, is make sure you're keeping your safety glasses on all the time. So I can pop one of these tiny ones in at each end, and then if the material I'm putting in the vise is fairly short, these aren't going to get in the way. So I mean, I've used these once or twice as well for that very use, so I'll keep those on hand as well to hold my parallels in position. So well, there we are, that's the little simple one-day project finished. Thank you very, very much for joining me in the workshop today. I hope you enjoyed seeing this being built. I'm quite pleased on how it turned out. I think it's going to be a very useful accessory to have for the mill vise as well. Also, thank you very much to all the subscribers to my channel and helping me get to over 1,000 subscribers recently as well. It's very, very pleasing for me to be able to do that. Also, thank you for all the comments. I mean, if you have a comment for me, anything basically, I'd like to make contact with people through YouTube. Any hints, tips or bits of advice you've got for me, anything you see that I'm doing wrong, please tell me. I won't be upset at all, but I'm learning all the time. Every time I come in the workshop, I think I learn something new just about every time, so you won't offend me in any way. Anyway, that's it for me basically. So hope to have another interesting video for you very, very soon. So thanks very much. Bye bye for now.